Mars has always been a source of fascination for humanity. Its reddish glow in the night sky has inspired countless stories, from ancient myths to modern science fiction. But today, what once seemed like fantasy is turning into a real possibility. The race to colonize Mars is on, led by companies like SpaceX, NASA, and other international space agencies. But how feasible is it, and what challenges stand in the way? Mars, often called the Red Planet, is the closest planet to Earth that has the potential to support human life. It has seasons, polar ice caps, and a 24.6-hour day, which makes it more Earth-like than other planets in the solar system. However, the environment is far from welcoming. Mars has an incredibly thin atmosphere made mostly of carbon dioxide, meaning humans can't breathe there. Temperatures are freezing, averaging about 80 degrees Fahrenheit, 60 degrees Celsius, and the planet is bombarded with radiation due to its lack of a magnetic field. One of the biggest hurdles in colonizing Mars is getting there. The average distance between Earth and Mars is about 140 million miles, and the journey can take 6 to 9 months depending on the alignment of the planets. SpaceX, led by Elon Musk, is making significant progress with its Starship rocket, which is designed to carry large payloads and humans to Mars. NASA's Artemis program is also laying the groundwork for deep space exploration that could include Mars. But even with these advancements, the trip is risky. Astronauts will face prolonged exposure to radiation, muscle and bone loss due to microgravity, and the psychological challenges of isolation. Once humans arrive on Mars, the challenge of survival begins. Building habitats that can protect against extreme temperatures and radiation is essential. Scientists are working on concepts like inflatable domes, underground shelters, and even structures made from Martian soil using 3D printing technology. Water is another critical resource. While Mars has ice at its poles and possibly underground, extracting and purifying it will require advanced technology. Food production will also be a challenge, as crops will need to grow in controlled environments using limited resources. Energy is another key issue. Solar power is the most viable option, but dust storms on Mars can last for weeks and block sunlight, potentially disrupting power supplies. Scientists are exploring nuclear power as a backup solution to provide consistent energy for habitats and equipment. Despite these challenges, the potential rewards of colonizing Mars are immense. A human presence on Mars could serve as a backup for humanity in case of a catastrophic event on Earth, such as an asteroid impact or climate disaster. Mars could also offer opportunities for scientific research, from studying its geology and climate to searching for signs of past or present life. In the long term, Mars colonization could pave the way for humanity to become a multi-planetary species, exploring and settling other worlds in the solar system and beyond. However, the ethical and practical concerns of colonizing Mars must also be addressed. Critics argue that the enormous cost of Mars missions could be better spent solving problems here on Earth, such as poverty, healthcare, and climate change. There's also the question of protecting Mars itself. If microbial life exists on the planet, introducing Earth life could contaminate its ecosystem and obscure scientific discoveries. In conclusion, the race to colonize Mars is a bold and ambitious endeavor. While the challenges are daunting, the progress being made by SpaceX, NASA, and other organizations shows that it is not just a dream but a possibility. Whether Mars becomes humanity's second home will depend on overcoming technical, ethical, and logistical obstacles. But one thing is certain, the journey to Mars will push the limits of what we are capable of and redefine what it means to explore the unknown. 4.0